what are the informations you can obtain from the function. Okay, from the first derivative, how to obtain the saddle points, the maxima and minima. Okay, those kind of things has been, whether a function is an increasing function or decreasing function for a particular domain. Those kind of information we can get from the first first derivative. Suppose let me assume that this is the function. Okay, this is the function, means if the first derivative is like negative, means then it's a decreasing function. Here the first derivative is negative. Similarly, the first derivative is positive, means it is a increasing function. Function is increasing function. This is a decreasing function. Okay, the first derivative is 0, means that's where your critical points or saddle point is critical points. Okay, you can able to attain the critical point. Okay, if for example, if I'm giving you, if we have an arbitrary function, okay, you can able to obtain the critical points. You got it right? You can able to obtain the critical point. Whether it can be a minimum or maximum, that can be obtained from these conditions. Okay, you have to take the first derivative. For example, for this equation, we are getting the minimum point at x is equal to minimum point at 1, right? At y is equal to 1. That's where the minimum point is happening. Okay, and x is equal to 0. That's what this point is. Okay, substitute your once you obtain the y derivative, substitute a value just before 0. Okay, which means minus 0.5, and see whether the sign of that. If it is negative, means then it is a decreasing function here, and substitute just after 0, y dash just after 0. Substitute the function plus 0.5. If it is positive, means then it's an increasing function. Then you can guess that it's a minimum point. Okay, the vice versa. Similarly, like if it is increasing function, okay, this is your critical point, means okay, substitute the value just before that. If y dash is positive, means the function is increasing and decreasing. Okay, so this is the information we can obtain from the first derivative. Now let me go to the second derivative. What is the information we can obtain from the second derivative? As I explained earlier, okay, yesterday, okay, this kind of response is nothing but something called concave up, and this kind of response is something called concave down. Concave down. Okay, if y dash is positive, means then the function is a concave up function. Concave up function means you will be getting a minimum value. You got it right? The function is decreasing, then it's increasing. Okay, so you will be getting a minimum value. The function is concave down, means y dash is negative, means the function is a concave down function. Concave down means it's an increasing function, then it decreases. Okay guys, so this is the information we can get it from the second order derivative. Similarly, if y dash is equal to 0, means what is the information it is telling you? It tells you that it's a point of inflection. Point of inflection. What does the point of inflection means is, okay, it is changing the, for example, let me assume a function like this. Okay, this is where it changes its concavity, right? Here up to here, it is concave down. From here onwards, it is concave up. This is where it changes its concavity. This point is nothing but point of inflection. Okay, therefore y double dash is equal to 0 will tell you that wherever the y double dash goes to 0, that particular point will tell you that point of inflection. Otherwise we can say that if y double dash doesn't exist on a point, does not exist on a point, then those points also will give you the point of inflection. For example, consider the same case here. Consider the same case. Okay, here the y double dash is 0, right? It changes sign into y double dash is 0. Let me write the opposite way. Opposite way means this one. Here you can see that y double dash is infinity along this point. Y double dash does not exist because y dash itself is like the slope will be like infinity. So how can we obtain the slope infinity? Something like this. I hope it's clear for you. Okay, suppose it is something like this, means here the slope will be like does not exist. This is also a point of inflection point. Here the slope is 0. Slope not so y double dash is 0. That is point of inflection point. And here the y double dash does not exist. It is also a point of inflection. Okay, that's where it is changing its concavity. Okay, so far I have given you a lot of information about the graph functions. Okay, suppose I'm giving you a graph, arbitrary graph. What is the information you can get it from the graph? Everything has covered.